Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about covariance of the random variable x and y. In my previous video, we have discussed about joint moments about mean. In that concept, the one of the second second order joint central moment M11 is already defined. That M11 is called the covariance of the random variables x and y. Now here I am going to define definition of the covariance between the random variables x and y and the correlation coefficient. So consider two random variables capital X and capital Y. The second order joint central moment M11 is called the covariance of the random variables capital X and capital Y, and it is denoted by covariance between the random variables x and y is denoted by covariance of x comma y or c suffix x comma xy or m suffix 11, and it is defined as expectation of x minus mx into y minus my. Now here m suffix x is the expected value of the random variable x, my is the expected value of the random variable y. So that is mx is equal to mx is the expectation of x, mx is the expectation of x, my is the expectation of y. In terms of integration for the continuous random variable, covariance of x comma y is equal integral minus infinity to infinity integral minus infinity to infinity x minus mx into y minus my giant probability density function into dx dy. So that is the definition of the covariance between two random variables x and y. And the correlation coefficient. For the random variables capital X and capital Y, the normalized second order central moment is called the correlation coefficient. So the correlation coefficient is denoted as rho, and it is given by mathematically the correlation coefficient rho is equal to c suffix xy divided by square root of sigma x square sigma y square. C suffix xy is the covariance between the random variables x and y. Sigma x square is the variance of the random variable x. Sigma y square is the variance of the random variable y. So which is equal to sigma xy divided by sigma x sigma y, which is equal to sigma xy is the covariance between two random variables, that is expectation of x minus mx into y minus my divided by sigma x sigma y. So this is the definition of the correlation coefficient. So the range of the correlation coefficient is -1 to +1. If capital X and capital Y are two independent random variables, then the correlation coefficient is equal to 0. If the correlation between two random variables x and y is perfect, then the correlation coefficient rho is equal to ±1. If x is equal to y, then the correlation coefficient is equal to 1. So these are the some important conditions of the correlation between the random variables x and y and the correlation coefficient between two random variables x and y. Some important properties or conditions.